jacket, and wasn't ready to
click, and that should be good.
Go that bold yet. Okay, my name is Ryan Condron. I'm going to be talking about, not blocking the slides, I'm going to be talking about Lumerin and Morpheus and the architecture and design. Oh, we are scrolling. Awesome. All right. Okay, cool. So a little bit about myself. My name is Ryan Condron. I'm the CEO of a company called Titan. It can be found at titan.io. It is a private mining pool. So we deploy private mining pools to large miners for Bitcoin mining. I also founded a protocol called Lumerin back in 2018 that is a decentralized data routing system. So it uses Web3 contracts to broker the opening and closing of sockets directly between peer-to-peer nodes. And you'll see why that's very relevant very soon. I got into Bitcoin and crypto towards the end of 2012. My buddy Kyle came to me and told me about this crazy thing called Bitcoin and that we could mine with it. I thought he was crazy. I thought we were brute forcing SHA-256 for the Chinese. And I had to look into it more before I committed to anything. I found out that it was incredibly cool technology. Started building GPU rigs and stuffing them in our garage. Shortly after that, in 2013, we started ordering a bunch of ASICs and shoving those into rooms in our house and running extension cords literally all throughout my house trying to get to every single circuit. At one point in 2013, I remember going into the addition of my house and looking at the thermostat. It was over 125 degrees in the addition, and I don't even know what my neighbors must have been thinking I was doing because all the windows were open. It sounded like a jet engine. I tell them, oh, I'm mining Bitcoin, and to them that was like I was running a grow operation or something. They had no clue what I was doing. From there, we realized that we could mine altcoins, and we could actually ROI on our hardware a lot faster if we mined altcoins and then just sold it into Bitcoin. Some of our records where we'd ROI on our hardware is in little as 7 days. My buddy actually ROI'd on his hardware in like 3 days with one of these coins. And that was just a fun time. We realized a lot of these altcoins didn't have stable mining pools, so then we started deploying mining pools. We actually deployed one of the original Doge pools in 2013, and we ran about 80 different mining pools through 2013, 14, and 15. All that to lead to 2018 when we started seeing a real centralization issue in the Bitcoin network around mining. We started realizing that we could never fully decentralize hash power, so we had to find a way to decentralize the control of hash power since we couldn't actually decentralize the devices themselves. We could keep them distributed, but they're still centralized in control. So I wrote a paper called The Decentralization of Control, which then led to the Lumerin protocol, which is decentralized data stream routing. So that's a very abridged version of the last 11 years of my life. And before I get into this concept of Morpheus and Lumerin, I want to touch on some design principles because it's really hard for a lot of Web 2 engineers moving into the Web 3 space. And we see it in a lot of the architectures that we're losing some of the key design principles when you move into a decentralized system. So I want to tell you a quick story about this guy named John, okay? And John was born in Ireland. He immigrated to Philadelphia, and at the age of 29, he was actually quite successful. He was running a really amazing print shop. And now when he was 29, he was given a very, very important document. And this document was a draft. It actually hadn't even been signed by the authors of the document yet. And over the course of the summer, it was going to be signed by 56 different delegates. But John was tasked to make copies of this document and make sure that it was distributed accordingly. So John made 200 copies of this document, and he spread it out. And as of today, 26 of those 200 copies still exist. And the reason is because that document was actually printed 249 years ago. And if John wouldn't have printed 200 copies of that document and spread it out to 13 different colonies, we would have had no collaboration and acknowledgement of the authority and authenticity of the Declaration of Independence. The realization of the importance of redundancy in data and authenticity in data is a very serious matter. And the more important the data becomes, the more important the authenticity and the tamper resistance and the inability to control the data. So what we're doing here is incredibly important. We have really the opportunity at this point in history to encapsulate human knowledge and make sure that it remains tamper resistant, unedited, free. And that's really what we're focused on. So this is our Declaration of Independence. So the design principles that I want to push forward here and the core concepts I really want to stress is one is no SPOF, single points of failure. That means no centralized servers, no centralized data stores, and no centralized routers or relays. Now, if you're coming from the Web 2 world, like I understand if your brain's melting right now, because it's a hard concept to understand how you're going to build anything under these precepts. But that's what a scalable decentralized system that is tamper resistant, this is what it takes. We can't have central points of failure. Number two is a single software solution. That means the node is the node. Whether you're a provider, whether you're a user, it's a common code base, okay? So if I'm running an AI model or an AI agent as a user, it's the same exact code that a provider is running on their machine. And we're doing a peer-to-peer network. It's a node is a node. So that's the second core concept. The third concept is minimal on-chain transactions. So this is the other thing that I've talked to a lot of engineers about through the years. Because you're working with a consensus protocol and because you're working with a decentralized data store, it is very slow and it is very expensive to come to consensus. That's just the reality of it, is you have, thousands of nodes, if not more, having to agree on what is truth. And that's slow and expensive. And honestly, if you want fast, you have to sacrifice decentralization. So anytime you see faster block times, or anytime you see, hey, we come to consensus in, a quarter of a second, it means they've sacrificed decentralization in order to get optimization. And that's just a natural design pattern. So reads are incredibly cheap. Okay, if you're running the node locally, you're just going against your local host, you can read the data all day long. You have a local data store. If you're going through a third-party provider for your node, you're limited a little bit with your read, but it's still very cheap. Okay, but writes are incredibly expensive because you're actually updating the state of the network, and it has to come to consensus. It's slow and expensive. So third, minimal on-chain transactions is an absolute must. We can't write every single transaction to be on-chain. It's just not scalable. And number four is agnostic as possible. So multiple blockchains, right now EVM compatible. Most of our smart contracts are just going to be in Solidity. That's the general best practice right now. So we're sticking with EVM for now. It doesn't mean we're always going to be only EVM. We want to obviously move into other ecosystems through multiple blockchains. And then model type agnostic. It doesn't matter what type of data the model is for, whether it be audio, video, whatever. It has to be data type agnostic. All right. Second, design principles, privacy and security. I knew we were going to have this talk. Number one, prompts and inference. No one should know what I am asking except for me and the person I'm asking. Okay? Goes back to the first principle, is no centralized data stores, no centralized servers, no centralized relays. Okay? If I have a relay at any point in this infrastructure, it means someone else knows what I'm asking. And the only way to get around that is I have to obviously provide encryption keys, and now we're just making our model convoluted. So we can actually do a peer-to-peer inference and prompt architecture. So only myself and the provider knows what I'm asking. And even that can be an issue, and we'll work around that eventually, but for now, this is pretty good. And finally, node locations. Okay, a common attack vector is when you have providers that are public accessible, someone can just get at your list of providers and just DDoS you, take down your entire network. So the goal is to make providers as anonymous as possible. If they can't be anonymous, because we are registering them on a public blockchain, we will have to have them behind firewalls, or sorry, VPNs or load balancers, and it's just going to be like a general website at that point. There's ways to become fault tolerant in that regard. User nodes will be only visible to the provider during a session. And then obviously we encourage best practice with using proxies, load balancers, VPNs, and other obfuscation methods. All right, let's get into the meat of it. What's the design pattern? It's actually very simple. You have a session from a user. And remember, Morpheus node is a Morpheus node. The router contract is kind of the brains that's connecting all the other contracts together. The token is fed to the router contract for payment. Payment goes to the provider. The users are opening a session. And then inference and prompts are streaming between provider and user. Now, if I'm using terms incorrectly, it's because I've come from the Web3 ecosystem and not necessarily AI ecosystem. So I'm still learning, so have grace with me. But this is my understanding of the terms to be used. Okay. So why are we working with Lumerin? What's Lumerin really offering? Well, I wrote the Lumerin paper back in 2018, and my team has been spending the last 2.5 years building it. We actually launched it into mainnet, which happens to be Arbitrum, back in September. And it happens to be the exact pattern that Morpheus needs to be a fully decentralized architecture. It's amazing how things like that line up. It's almost providential. So this was the original architecture layout for the Lumerin protocol. It's probably a little hard to read there. I'm going to go down and walk through kind of the more workflow ones. Essentially, it's the same exact pattern where you have a sender and a receiver of data. And what we're using it for with Lumerin is a hash power marketplace. My background is mining, and we see a need for decentralizing the control of hash power so that we have miners that can put up a smart contract on the Arbitrum network for a certain amount of hash power over a certain amount of time. Anyone, anywhere in the world can purchase that hash power through an Arbitrum contract, and immediately a socket is opened from the miner's node to the buyer's node, and it streams the hash power in real time as the escrow on chain drips payment to the provider. So it is a real-time flow of data from source to destination that is paid out on Arbitrum. And then if at any point it needs to switch, or the buyer wants to switch destinations, they can literally route that hash power wherever they want. So it's a real-time data router. And we started with hash power. This pattern can be used for video, it could be used for files, it could really be used for anything. It's decentralized piping based on smart contracts, and which is why it is a natural fit for Morpheus. So this is the block diagram for the core Morpheus node. I put a Lumerin logo next to the pieces that are actually already built and in production. So we already have the Web3 token, the key store, the wallet UI, all the proxy pieces, all the API pieces, all the peer-to-peer management systems. So a good chunk of it is already done and tested for the last 2.5 years. So it's a really, really good start for this size of a project. I mean, we just bootstrapped 2.5 years of development. It's hard to beat that. So I'm going to go past that. So Morpheus smart contracts. So this is going to be the layout of the smart contract ecosystem. Okay. So we have 8 main contracts. If I'm missing some, I've simplified it quite a bit here, just for the sake of time and for the slides. It all spearheads at the first contract in the upper left, which is the ecosystem registry. Okay, so this is basically the versioning contract. So because Morpheus is going to be across multiple chains, that can get very, very messy tracking where all the smart contracts are, where all the addresses are, which versions you have. That's just it's a sloppy way of doing it. So we're starting with an ecosystem registry. So when we deploy on a new chain, first contract that goes in is the registry contract for the ecosystem. Every other contract that gets deployed gets registered into the main contract. So anyone that wants to develop against Morpheus, anyone that wants to have a Web3 app or anything against Morpheus, all they have to do is call the main ecosystem contract for that chain, and they can pull in all the other contracts from there. Then if we ever need to version a contract, we simply update the ecosystem chain, and everyone's good to go. The other notable is there are little white boxes in all the different registries. Those are whitelists. So there is an aspect of trust. We have to trust good actors in the provider registry. We have to trust authenticated LLM models, and we have to trust good-natured agents to start. The reason is because we're still very new in this ecosystem, and there's a lot of potential hazards that we just don't even know yet. So to start, as we tiptoe into more and more decentralization, we are going to start with a whitelist. We're going to build reputation for providers. We'll build reputation for models. And as the ecosystem matures and as the technology matures, where we can actually do proof of inference, we can do proof of models, we can do proof of agents, then we can start releasing the whitelist and we can open it up. Okay, but we want to be very slow on that because those are natural attack vectors. You can have bad actor providers very easily. You can have bad actor and bad models or just nefarious agents very easily. So these are the main areas that we're going to start whitelisting and slowly open it up over time. So how does this work? This is the basic user flow. Okay, now once again, this is very high level, and this is because this type of talk can get very arduous when it's this late in the afternoon, and most of you, unlike me, have not had a Red Bull. So I'm going to stay very high level. If you want to get lower level, all of the logic trees, all of the flows, decision diagrams, all of it's going to be uploaded into a Git book, probably next week, time depending. So we'll have the full architecture docs available, so you can start digging in and seeing what the actual user interactions are going to be, what the transactions are going to look like, what the read receipts from the providers are going to look like. All that's been flushed out and will be uploaded to a Git book shortly. So essentially, let's just walk through this. At a high level, it's essentially a user selects a model inside their UI. And the moment they select a model, remember reads are very, very cheap. Their node is going to reach out to the Morpheus router contract, and it's going to pull down a list of endpoints for providers. The user node is then going to loop through those endpoints, and it's going to build a best response scenario of which provider to choose based on lag as they ping each of the endpoints, based on reputation, based on cost. Okay, so once the user has this is the best provider for you to select, the user is going to request a session with that provider, and they're going to put a max bid of how much compute they're going to want to spend, okay? And this is the essence of a session, okay? The provider at that point is going to have a maximum amount of compute. The provider can't just keep taking infinite sessions. So the provider has to actually accept the session, and if the provider says, yes, that's fine, the user then is going to open a session by submitting an on-chain transaction to the router, and it's going to open a session. Now, once the session is open, between open session and closed session, the user is free to send prompts to the provider, and the provider will honor those prompts, and there will be a free flow of back and forth. And that session could be open for now we're saying 24 hours, but it could be open for days, maybe weeks in the future, depending on the risk profile of the provider before, how long they want to wait before they get paid. But this eliminates the need for having on-chain transactions for every single prompt, on-chain transactions for every single inference. It's really just opening and closing the session and setting a max amount of spend for that. At the end of it, the user is going to request a receipt from the provider, and the user is going to also submit a finished report of how well the provider did based on that receipt. That all gets submitted to the contract for closeout, and that's when the router does the analysis and does the payment, or allows the payment to be claimed by the provider. Okay, very simple model. We're trying to stay with happy path and whitelist to start, because you can very easily fall down the rabbit hole of gamification where it gets very, very complicated and convoluted. So we're sticking with simple. Let's get the model proven, and then we can start getting more complex to eliminate trust and open up the whitelists. So simple, get providers, select provider, open session, send prompts, close session, pay provider. Fairly simple. All right, so conclusion. Avoid points of centralization, okay? Privacy where possible. Portable code, a single client. So the provider and the user client is exact the same. Yep, on the next slide when it says questions, I will explain why. Adopt the Lumerin pattern. It's a simple pattern that's already been well tested. Deterministic interactions, so basically putting as much of the payment logic on chain as possible in a deterministic way. Whitelist until proofs, and then time is short, as David pointed out this morning. We don't have a lot of time to make sure that these models are safe from interference. So we're pushing very, very hard and very, very fast for this. And now we're down to questions, because I know some of you probably have a lot of questions. And if I can't answer them, I'm sure there's someone smarter in the room that can. Because as someone said earlier, the quality of the people at this summit is absolutely phenomenal. And I've had like such incredible conversations today. It blows my mind that we can get this high quality of people in one place for something like this. So okay, let's open it up. I don't know how much time I have, but thank you. Okay, let's do it. Ryan.
Yeah, so one question was, in the compute paper, it mentioned that inference was going to be free for users until a certain point. Is that logic captured in a smart contract, or is that?
Yeah, great question. So this is one of those things where someone writes a paper and they expect engineers to figure it out. What's that? Yeah, I had to throw in my 2 cents first. So the question was, essentially, compute is considered free, handled on contract. Is that right?
Oh, yeah, basically, like, I think the compute paper was saying that if I'm a user, I get free inference.
Yeah. So every 24 hours, according to the Yellowstone paper, there is essentially free inference provided to holders of more. Okay, it's almost like a subsidized AI compute every 24 hours if you hold more. Okay, this was written in the Yellowstone paper. It's really kind of a fascinating model if you think about it. It's not like a I give you token, you give me inference model. It's a I hold token, therefore I get inference every 24 hours in ratio to the entire network. Okay, it's really challenging the general pay-to-play model. It's almost like I have a stake in the network by owning the token, therefore I get, food stamps almost, or some types of subsidy. So, and as I said before, it's one of those things where someone writes the paper, and then it's like engineers are sitting there scratching their head going, oh, how are we going to do this? It's a cool model. But there's a natural limitation where what happens if you go past your subsidy? And how do you do that inside the same session where maybe I'm only allowed a certain amount of inference in a session and I'm in the middle of rendering something. I'm in the middle of, trying to get the data I need from this really powerful AI model, and I go past my daily allotment. Well, I can't just go out and buy more and get into my wallet and have it staked, because chances are that's not actually going to give me more compute on the network until maybe the next day. So how do I keep my session open? So we do have an answer for this, and in the current workflow model, the way it works is when I open a session as a user, I actually have to stake more in that opening of the session. This incentivizes me actually to close out the session sooner and to provide my report as a user. So a portion of my holdings of more actually gets staked into the session. And if I want to go over my allotment of subsidy for the day, that's going into my budget against the session, and that gets pulled out of my stake. Okay. Now I can never spend more than my stake because that's just economically not feasible. So that's the general answer to that is I will start pulling out of my stake if I go past my subsidy. Yes?
It was actually asked before, but what's the reason for having a single client for both?
Yeah.
And is that client supposed to be small enough that it could be utilized within a mobile application or something of that nature?
Oh, great question. So, okay, so the question is, why a single code base for provider and user? And is this single code base supposedly going to be small enough to run on a mobile device? Short answer is simplicity. When you start having multiple code bases for both user and provider, you have to keep things in sync. You have versioning issues. You have to make sure that you will eventually have a common bedrock, behind it, right? That you're going to consume libraries. You're going to consume into each. You'll have data redundancy. So for developer simplicity, it's a single node, and a lot of this is borrowed from just other crypto networks over the years, that this is kind of the model that we've adopted because we realize that it's too hard to run a open source project where you have so many different moving pieces and you have to make sure that they stay in sync with each other. So short answer is simplicity. And then to address the mobile app, probably not, honestly. The Morpheus node probably will not run initially on a mobile app, but keep in mind that there's no reason, like there's not substantial data storage, and there's not even substantial compute, because really all you're doing is your socket routing based on smart contracts. So if you offload the smart contracts to a third-party provider node, you don't have to run the node locally on your phone. So that piece is offloaded. And then if you have like a local really small LLM that you're running on your phone, awesome. But you don't really have to. So I'm thinking on the spot here. So yeah, short answer, yes, you could run it on your phone because it's actually really lightweight. It's just a socket router based on smart contracts.
Well, and maybe it's helpful for you to differentiate between the full node, which is what you're talking about.
Yeah. Yeah. So, well, full node and light client. So these are terms from the traditional crypto space when you're running a blockchain, right? So one's going to be like, do you have the full chain running locally? That's full node. A light client is you kind of have checkpoints on the blockchain that you run locally, and you get the full blocks from a third party. The reality is that the Morpheus node is running on top of another blockchain, so there's really no reason why it couldn't be just incredibly lightweight. There's no reason why it couldn't run on a phone, honestly. And I apologize, I honestly hadn't even really thought about it when I was putting together the presentation. Yeah.
You mentioned that Morpheus is going to be launched on different chains. What's the reason for that?
Accessibility, honestly, yeah.
Can you repeat?
Oh, I'm sorry. Yeah, I'm great at this, you can tell. The question was, I had mentioned in the presentation that Morpheus is going to be launched on multiple chains. And the reasoning for that is really accessibility. Not everyone is bought into every token ecosystem. There's a lot of Solana fans, there's a lot of Arbitrum fans, there's a lot of Binance chain fans out there. We're not being tied to one ecosystem or backing one ecosystem, because at the end of the day, it's freedom. And we should be able to deploy it as many places as possible and have as many accessible points as possible. Now, will those different ecosystems cross over with each other? So if you're running on Solana with a user client, can you talk to a Morpheus provider model on Ethereum? Technically, yes, but there's going to be a lot of bridging happening, and bridging is centralized, for better or worse. So I don't have that figured out yet. Ask me in a year. We'll get there. Any other questions? Cool, guys. Thanks for your attention. Appreciate it.